bit of this one, 4.2. Okay, we are going to investigate what is the rules of the probability. Okay, rules of probability. Okay, the first rule is going to be called complementary rule, or complementary. If we talk about what is a complementary event. Okay, complementary events. You see, if the event is going to be having rain tonight, the complement of that event would be there is not going to be rain tonight. So just a kind of negation of that event that we are going to use the complement, call it the complement of one event. You see, if this is going to be your, for example, if this is going to be your sample space, which contains all the possibilities, okay, and these are going to be some events that you are going to have in your sample space. If you consider an event, you know that it's going to be a collection of these outcomes. So suppose this is going to be the event A that you're going to be interested in. So your event containing 3 outcomes, 1, 2, 3. This big one is going to be your sample space. These are all the possibilities. So if you just, this portion is going to be your event. Anything which is not going to be in your event, this leftover would form a new set. This set or this event is going to be denoted by AC, and we are going to call it complement of the A. Okay, so each event would have a complement. So in your event, you are going to have some outcomes, the leftover, anything else into the sample space, which are not going to be in your event, is going to be called a complement. Okay, so that's a definition of a complement of an event. So the complement, okay, the complement of a given event A is going to be denoted, notation is denoted by a complement, AC, a complement. And what is this one? This is going to be containing all the outcomes which are not in A. So consist, okay, this would consist of all outcomes, okay, which are not in A, if you like, in which A does not, if you like, does not occur. Or is going to be all outcomes outside of A, if you like. Everything into the sample space, but not in A. We call it A complement. Now, as you can see over here, if you have the collection of the events that you have, A and the A complement, if you put them together, that give you the sample space. You see, note that what you have over here, if you have the collection of all the outcomes in A, union with, you put them together with all the complement in all the outcomes in the A complement, the result must be the full sample space, because the events are going to be either in A or A complement. So if you add them together, you get a sample space. You know that the probability of getting a sample space is 100%. So this means probability of A plus probability of A complement must be equal to the probability of S, which is 1 or 100%. Okay, so that give you the fact that the probability of A plus probability of AC is going to be equal to the 1. So we can find one of them. So for example, probability of A complement is going to be 1 minus probability of A, or the other way around. This is going to be called complementary rules, or the rules of complementary events. Okay, so this is the rule of complementary event. So if you want to find the complement of the given event, you're just using this formula, 1 minus P of A, or just 1 minus, or 100% minus P of A that you have. Okay, probability of having rain tonight, 40%. So the complement would be probability of not having rain tonight, would be 60%. Because the 40 and 60 all together, you must get 100% or equal to 1. Okay, any question?
Professor, I have a question about the convention you're using here. Does our book use a different convention? I believe it's A bar.
Very bad one. Yes, I know that. Never use that one. Yes, in your book they call
that
it
is listed
A-bar.
in the book, though, correct?
Yes, yes, it's very bad. Your book should change it. That's fine.
They're the same.
Yeah, they're the same thing,
Okay.
but we don't usually use it because A-bar in pure mathematics means the closure of a set, and the closure of the set is something quite different from the A complement, and that's very bad. You know, as statisticians, they don't care. They just use whatever they like. But if you are going to be a pure mathematician and you see A complement, it's something which is nothing to do with the A complement. That's why I don't use it, okay? Yeah, I didn't check that. I know that some of the statistics would use this one, okay, so don't use it. But it's the same thing in this case. Okay, we call it closure of A. This is in a couple of subjects in mathematics, especially there is one that we call it topology. When we get in topology, the closure of a set would be denoted by A bar. That's the one. I was given, you know, $500 to review a statistic book once. So the big thing that I wrote for them was A bar. And mathematically, I explained for them that it's going to be very much confusing if somebody take another course in mathematics and get the A bar. Okay, that's why I don't use it, but it's the same thing. In some of them, even they use A prime, which is also a very bad one. This is called the limit set. Okay, but that's just fine. So that would be, yes, the same thing. Thank you. Any question? Now we are going to have very nice problems when you get through this course, okay? And you know that you can switch it if you like, but for the time being, just one easy example, and we are going to give you two. We have two in your practice one. We're going to check it, but for the time being, you see at most one of them would be given, and then they ask for the other. Okay, so get to know that if you've been told that if the probability of A, for example, if is equal to the 0.05, which is going to be 5%, and they ask you to find what is going to be a P of A complement. Okay, so now you know that the relationship is, you just write the formula and you substitute to get the result. Okay, so this is going to be the case. So you say that the probability of A complement is equal to the 1 minus P of A. So this is going to be 1 minus 0.05. And if you subtract it, that gives you 0.95, which is the same as 95%. Okay, so the probability of A complement is equal to the 95%. Okay, this is all we can do for the time being. But I'll have two nice ones in the practice one, then we go to it. Okay, so that's a complementary events. It would have very nice role when we get to the a little bit more complicated one in future. There is something that in future we are going to call it probability of at least. We are going to use it, but for the time being, this is all we have for the first rule. Okay, any question? So get to know it, A complement, or the complement of the probability of the complement of the set. Okay, so that's going to be the first one. Now, the other one, the more serious one, is the one that we call it addition rule. that would be very popular and again very easy to find to use. We are going to be a little bit not difficulty getting more involved when we get to the multiplication. So let's have what is going to be addition rule of the probability. Addition rule of probability. Now what's going to be addition rule? We have to introduce a notation first. Okay, suppose two events are given to you. Suppose the events A and B. Okay, A and B are given. Two different events. Okay, now the probability notation. The probability of getting A or B, or probability that A or B occurring, if you like. A or B is going to be denoted, notation is denoted by, we're going to use two different notation. One of them is just in word form. You may say that P of A or B. We understand that you are talking about probability of A or B. Or the better one is this one. I'm going to use the second one, but you can use the first one too. A union B. Okay, again, we call it A or B. So the probability of getting A or B is going to be denoted by P of A or B, or just P union B. Okay, now the probability of getting both of them. The probability, okay, the probability of getting A and B at the same time, A and B is going to be denoted by, it's going to be denoted by what? It's going to be denoted by, this is the notation that we're going to use. You can say that probability of A and B, write it down in word form. Or we can use this notation. We call it intersection notation, A intersect B. So this notation, A intersect B, means A and B, both of them together. Okay, but this notation means either in A or in B, if you like, or A or B. Okay, any question? Now, what we would like to do is we'd like to find a formula for this one. Remember the definition of the probability, the classic one. The probability of a given event is equal to, remember, number of the elements, number of the outcomes in A divided by the number of the outcomes in the sample space. Or this one over here. Now, so we have to find a method that enables us to find out how many outcomes are going to be in A or B. Okay, this is the one that we need to know. So look at this, this situation we're going to have. So suppose this is going to be a sample space again. Okay, this is going to be a sample space S. So what I'm going to do, I'm going to pick A and the B. So suppose this is going to be A. Okay, this is A. And there are some outcomes in A. Okay, so suppose this is going to be outcomes in A. 1, 2, 3. And this is going to be 1, 2, 3. And there's going to be one here. Okay, so these are going to be the outcomes in A. Now I'm going to pick a B. Okay, so I'm going to pick the B, and suppose this is going to be B. Okay, so this B is going to be a new one. B is going to be a new one, and these are going to be the situation that we're going to have inside. Okay, inside the B. So event A is going to be the red one, event B is going to be the blue one, and the outcomes in those numbers are given to you. So what we'd like today, we'd like to count the members in these sets that we're going to have. Okay, so note that if this is going to be the case, we want to find n of A. Remember, n of A is a collection of all the members of A, all the outcomes in A. As you can see, how many do we have? Those red one is 7. So you have 7 outcomes in A. Okay, then you get the outcomes in B. Outcomes in B, how many do we have in B? You see 1, 2, 3, and the 2 here make it to the 5. So this is going to be the numbers in A and the numbers in B. Any question? Now we want to know how many members is going to be in A or B. Means how many numbers in all of them. Any suggestion? How many numbers in A or B or in both of them that we are going to have? The members are going to be, okay, somebody said 12, 12, 12, 12. Okay, let's see if you are going to be wrong. Okay, the suggestion is 12. And the reason that you say 12 is maybe, you see, start counting the members that we're going to have. How many members we have? You have to check the numbers in A, the red one. In the red one, we get 7. Okay, 7, 1 is going to be in the red. Then you have 3 blue here. So 7 and 3 would be 7 and 3 would be 10. The reason that you said 12, because you counted the red one twice. You see, when you count the elements in both of them, so you have to count each member once only. Okay, so no repetition that you're going to have. Any question? So that is the members in A or B. Now, what is going to be the numbers in A and B? What is going to be the members in their intersections, if you like, the common numbers, common outcomes? How many common outcomes do you have in these sets A and the B? Yes, that's correct. You have 2 members. You see between these two, any question? Now check this one. Can you find a formula now? Or can you write a formula? The formula that you are going to be interested in is going to be this one. You want to find the formula for because this is what you need for the probability. You want a formula for N of A union B. So this means you want to count all the members. Yeah, I missed you just a minute. Let's go back. This must be there. Do it again. Okay, we are back. Okay, you see, we want to count the members in A or B. So what we do, we count the members in A and we count the members in B. But the difficulty is going to be some of these members may be in A and B. So what you have to do, you make sure that you are not going to count them twice. These two red one over here. So what I'm going to do in order to not to count it twice, you have to subtract all the members that are going to be in A and B at the same time. You see, get this formula. And if you put it over here, you can see that, you get the 7 and 5. 7 and 5 would be 12. Okay, minus 2. Minus 2, that give you your 10 that you're going to have. Okay, if you are measuring computer science, you are going to use this formula in various formats. This is just for 2 sets. You are going to use it in 3 sets, 4 sets, etc. Okay, so this will give us a formula in order to find, all the members that are going to be in A and B. This obvious observation in mathematics, we call them, you see what you did, you include the members of each set, but you exclude the intersection. So that's why this is going to be called, okay, I'm going to make it official. This is called inclusive, exclusive, inclusive, exclusive formula or principle. It's very popular, okay? So the format is going to be if A and B are given sets, if A and B are going to be given sets, collection or whatever it is, then the number of the elements in A union B, you include the members in A, include the member in B, but you have to subtract the members in their intersection. You see, that's what we call inclusive exclusive principle or inclusion exclusion principle. And when you are measuring on those, especially in computer science, this is for 2 sets. You can do it for 3 sets. If you have a 3 set, just just write it down for you for your information. So similarly, if you like, if 3 sets are given to you, so if A, B, and C are going to be given sets, then this is what you have. See, for the 3 sets, this is your situation. This is A. Okay, this is going to be the set A, for example. This is going to be the set B. And there is going to be a C here. You see a C here. Again, you have to make sure that you are not going to count one element 3 times or twice. So this is going to be your formula. N of A union B union C means the members in all the 3 sets. You have to include the members in each set, N of A, N of B, N of C. You see? Then you have to subtract their intersection. So it's going to be minus, subtract intersection of A intersect B. Okay, minus A intersect C, minus B intersect C. See what you do, you're just taking out these parts. You see, you're taking out these parts that you're going to have. Okay, but the difficulty is going to be, there is going to be a place that it's, you see, look at this one. This is the intersection of all the 3 sets. So when you take this out, this part is going to be taking out of the collection altogether, and it's not going to be counted. So that's why you have to add N of A intersect B intersect C. You see again, inclusive, including the sets, excluding the 2 by 2 intersection, but you have to include the intersection of the three sets. And it can go on forever. You can do it. What we do it for two sets in a statistic, but if you're doing those type of we call it counting problems, this is going to be a situation that you're going to have. Okay, so what is the connection with the formula that we are going to be interested in? Remember, we are interested in the probability of A or B. You know that probability of A over B is the number of the element in A over B divided by the sample space. So divide all these by n of S and take the probability. That give you the additive rules that we're going to have, okay? So it's just for information. So the conclusion is going to be, see, this is going to be the case. I just change it to the probability, note that. So what I have, I started again for the two sets, the number in A union B equal to the number in A, number in B, minus the number of A and B. Divide by the n of S, numbers in the sample space. So that gives n of A union B divided by ns is equal to the n of A. Okay, n of A divided by ns, n of B divided by ns minus n of A intersect B divided by ns. According to the definition that we talked about the other day, this is classic probability. So this would be the probability of A or B. This would be probability of A. This would be probability of B minus the probability of A and B. This is it. This rule is going to be called addition rule. So that is addition rule of probability. I just proved it for you so that you can see really what's going to be the connection that we're going to have. It's very easy to apply in the problems because as soon as they say probability of A or B, you know that this is going to be OR connection. You write the formula and the probability would be exactly like the one that I did over here. You just find the probability, substitute, and do that. Any question? So let's try it. Give an example. We give one of them on this quiz. A straightforward problem, and you get one again on the next one. So that's what we addition that give probability of A or B. After your quiz, we are going to check this one, probability of A and B. That would be a little bit more involved. It's not as easy as this one. You have to go through something else to be able to find it. Okay. Any question? So let's have one straight forward question and then go to the practice quiz and we do the one from that one. Okay, example. That's it. If these examples, they talk about, they are going to talk about a story for you, but you have to read the last line. The last line, they ask for the probability of something or something else. So you know that's OR connection. You write your formula, substitute, and get the result, okay? So for this one, we are looking at a political rally involving Republican, Democrats, and Independent, and we ask a question. Okay, so at a political rally. Okay, sorry, that's a rally gathering. And there are 20 Republicans. Okay, Republicans, 13 Democrats. Okay, Democrat. And 6 independent. 6 independent. Okay, so that's a population that you have. 20 Republican, 13 Democrats, 6 independent. So 20 and 13 would be 33, and the 6, 39 is your sample space. Okay, independence. So what we're going to do, we are going to pick one person out, and we want to run what's going to be the probability question. Okay, it's always the case. So pick one person out. If a person, okay, if a person is randomly selected, a person is randomly selected, we want to find the probability, find the probability that the person, he or she, or person, okay, he or she is either a Democrat, or an independent, Okay, independent. So this is going to be the question that we're going to have. So as I told you, when you read this type of problem, you just read the last line to see what they are asking. You see they're asking for or. So this is going to be or connection. The person to be Democrat or the person would be independent. So you just use some symbolic format. You have to give us the formula. Okay, which formula are you going to use? And then check this one. So probability, this means if in symbolic form, you can use A or B if you like, but you are interested in what? The probability that the person is going to be Democrat or independent. So this is going to be the missing part. So you realize that you're dealing with the OR combination. So when it's OR combination, you have to use the addition rule. Okay, so you write your formula. So the formula that you have to use is probability of, you can say D or D union with I, or I is equal to probability that the person is a Democrat, probability that the person is independent, minus the probability of person to be Democrat and independent. Okay. So you need a sample space. So the total number in the sample space N of S is going to be what? You have 20 Republican, 13 Democrats, and the 6 independent. So that total would be 39. Because you need to use that formula, as you see, to find the probability of each one of them. So there you are. What's going to be the result? Probability of Democrat or independent is equal to probability of getting a Democrat. You see, it's going to be how many Democrats do you have? In this case, we have 13 Democrats. It's going to be 13 out of the total number, which is 39. So 13 out of 39, we get the Democrats. Plus independent. How many independent do you have? We have only 6 independent. 6 out of the total, which is 39. Okay, minus how many people can be Democrat and independent at the same time? You just check, this category does not exist. Okay, because in this information that's given to you, the person is either a Democrat or is independent. So in this case, this category is 0. So you've got to be careful. Sometimes it's 0 in your book. They open up a section about when it's get to 0 and they call the sets to be disjoint. I ignore it, let you just using common sense, because there is another terms very much similar to this one, but quite different when we get to the multiplication rule. So we don't want to be confused. Okay, so we just check there is no category of this form that to be a Democrat and independent at the same time. So that gives 0 over 39. Any question? You have to simplify. This is equal to the 0 is out. 6 and 13 would be 19. So probability of getting a Democrat or independent would be 19 over 39. You can leave it as a fraction because it cannot be simplified, but a percent would be better if you just give us a percent. We accept this one if you give us, but in percent, this is going to be something like 49%. So if you pick 1% out, there is 49% chance that that person is going to be either a Democrat or an independent. Okay, so this is the way you are going to handle this problem of the OR connection. It's not a difficult problem, okay, because they just give you the expression OR. So just use some symbols for those two events that's given to you. Write your formula, then substitute. You have to give us the formula to find out that you did it with the additive probability rule. And that's it. Any question? A multiplication, we do it after your quiz. It would be involve some other things. So now we can go and check the one that we have on that practice one. Okay, just make sure you understand it. 6 topics that will be interesting. Okay, so get to know it. That is going to be additive rule or addition rules of the probability. So let's check the one which is on the practice one to learn how we are going to handle these problems. Okay, so that's going to be practice quiz number 2. Okay, this quiz would be contains 2 parts. The first part is going to be the idea of the percentiles. Okay, percentiles and the box plots. And the second part would be probability. So it's a 6 questions, 3 each, 3 probability and 3 from the other one. Okay, I'm going to do it from in the reverse order because I want to make sure we get enough time to spend on the probability first. So I go with the number 7 first. Number 7. This is the number 7 that I'm going to summarize it. We like this type of problems from now on. We give you the information as a table and you should be able to read it. Okay, so this is the information that we have on number 7. We're just checking some information regarding the people who smoke or how they are going to smoke. So we have the information here. You see we have 300, the men and the women. The collection is 996 and we divide them into different categories. Okay, non-smoker, occasional smoke, regular one, and heavy smoker. So this information given, and then we pick one person out and we ask the question, what is the probability that that person is going to be either a regular or heavy smoker? You see this or, so you realize that you're dealing with the additive probability or addition form. And it's going to be the same for the other one. Okay, and then you write the formula and then you're done. You need some symbols, you know, to take care of these. You can, so this is the way we are going. Are you ready? So this is it. We go to the part 1 and we check to see what question do we have to answer. Okay, this is going to be part 1. I'm going to write this this chart again because we usually, when this chart is given to us, we are going to add one column more column and we add these numbers because that addition would be useful when you want to find the probability. Okay, so this is optional, or when you have to, you come back and you check those numbers. But this is the way I organize this table for myself. Okay, so this is the given table. So the information that I have. So I have the men here. Okay, this is the men and the woman. Again, you don't have to, you can go ahead and get the result. So the first column is going to be non-smoker. I'm going to use this notation for the non-smoker. Okay, this is going to be the case. And non-smoker, I have 339 men and 377 women. Okay, but I add another column here. And I'm going to call these total. Okay, total because I may need it or I come back to it. Then the other group are occasionally a smoker. This is a 32, 33 and the 32. The next group are regular smoker, 61, 84. Okay, and I have heavy smokers, and heavy smokers are 34 and 36. Okay, so I'm going to get that column. I add one column. I call this one total. Okay, and they are going to be useful to use them. Okay, so what I have over here, just want to have a number so that I can be quick to write it. Okay, write it down in this format that I have. You see, if you add all these numbers together, you should get 467. And if you add all these numbers together, that gives you 529. And if you add these together, that should get them 996 that you'll be given the total population. You can check this total as well, and or check it as you need it. For example, I will need the regular smoker. You can do it later, but I can put it over here. So it's going to be 145. Then I need a heavy smoker. It's going to be 70. You can do the other one as well. Okay, just double check, but you don't need it in this case. Okay, this is going to be 65, and this is going to be 16. Okay, 11, 7. If you add all these numbers, that gives you 996 as well. Any question? So these are going to be the total. So now we can go and check the question. We check the question for the first part, what you need for the first part. The first part, you pick one person out and you want to know what's the probability that that person, you see, for the first part, of getting a regular or heavy smoker. So you want to check the probability that giving a regular smoker, this is the notation that I use, or heavy smokers. If you don't like this notation, you can call it A or B. We don't mind, but you have to give us a formula that you use. Any question? So that's OR connection. So write the formula. You know the formula. It's going to be probability of the first one, regular smoker, plus the second one, probability of heavy smokers, minus the probability that the person to be regular smoker and heavy smokers. Okay, so that's the addition probability rules that we have. Now substitute. You substitute each one of them. You see, for each one, this is going to be equal to. The bottom one is the total number, which is 996 for the sample space. The top one is the amount that you get over here. You see, you want a person to be regular smokers. You have 61 men, regular smoker, and 84 women. So you add them together, the total number of the regular smoker is 145. 145. Any question? Then you need the heavy smokers. The bottom one is the total 996. Heavy smokers. You have 34 men and 36 women. So we add them together, that gives you 70. That's why you need these totals. Okay, so that gives you 70. Any question? The next one, you check to see if this category is possible. So the bottom one is 996. So what category is this one? A person to be a regular smoker and heavy smokers. Can we have such a person? A person to be regular and heavy smoker is impossible. So in that case, this category is 0, because the person can be regular smoker or heavy smokers. Okay, so that last part is equal to the 0. So you have to add 145 and 70, and then get the result. So the probability of that person is going to be regular smoker or heavy smokers is going to be equal to, you add this, it's going to be 5. Okay, 11, 215 over 996. Again, you can leave it because it cannot be simplified, but it's better use your calculator to give us percent. In percent, it's going to be 21.6%. So probability of we get a regular smoker or heavy smoker is almost 21 or 22%. That the rounding part is not going to be a big deal. Okay. But basically, the numbers that you have, there are no decimal places here, or there is a 0 decimal place. We usually go 1 up. Since there is 0 decimal places for the given one, 1 up would be 1 decimal place. This is the way we do it if no instruction is given to you. So if these numbers would have 2 decimal places, you have to go with the 3 decimal places here. Okay, that's a general one. But again, for this group, it's not going to be a big deal. Any question? So that's the first part. 2 part, second part. What's the second part? You want to get a man or heavy smoker. Again, it's or combination. Since it's or, so use the addition rule, a man or heavy smoker. So there you are. For the second part, you want the probability of getting a man or heavy smoker. Again, if you don't like this notation, call it A or B. Okay, the formula, again, probability of getting a man plus probability of getting a heavy smoker minus probability of what's going to be this category, getting a man who is at the same time heavy smoker. Man and heavy smoker. Any question? Go back to the formula, again, you get it. It's going to be equal to the total 996 men. How many men do you have? What's the answer to this one? What is the total number of men? You see, for the men,
467.
467 is correct. Yes, 467 is correct. You see the men? You have 339 non-smoker, occasional, regular, heavy. So the total is 467. That's why I ask you to write the totals. Okay, total of the men. The total men is going to be 467. That's it. So this is going to be the probability of, again, use your calculator to change it into the percent. Okay. If you change it into the, oh, I'm sorry, this is the first one, I haven't done that. Plus, second one, probability of heavy smokers. So this is a 996. Heavy smokers. We have 2 groups, the men and the women. Okay, heavy smoker 34 and 36, 70. So that gives you 70 out of 996. Question? Minus. The next category, what's the next one? The next one is, you want the person who is a man and at the same time heavy smokers. Man, heavy smoker. Man, heavy smoker. 34. Okay, man, heavy smoker. So we get 34%. Okay, you simplify it. You can add these 2 together and subtract the 34 or the other way around. So, or just all of them together. This is the way I do it. I add these 2 together first. Going to be 7, 13, 537, 996. Then minus 34 over 996. Okay, so it's going to be 996. And the top is going to be 503. and using your calculator, that give you 50.5%. So the probability of getting a man or a heavy smoker is going to be almost 50 or 51%. And then you're done. Okay, that's the OR combination that we're going to have. Any question? So we cannot talk about the AND combination because that would be the next rules of the probability. So we give a table. We would like to be check to see how you read this information from the table. So read it carefully, write your formula, and then you substitute. It's not going to be anything complicated, if you like, but you have to practice to make sure you understand what's going on. Okay, any question? So that would be one topic. So you have some in your book, quite a lot. If you want to practice, okay, for this one, and probably on your web assignment or the web. Okay, so that's the first question. The second question is going to be, you see, we are going to create a situation and we ask you to find easy probability, but would like you to make a comment, okay, for us. What's going to be your understanding of this problem that we're going to have? So for this group of problems, we are going to set a range or a level for arguments. For the time being, you see if the probability of something is going to be less than 5%, okay, we are going to consider it to be, just give you a remark before going to, see, we call it our significant levels, if you like. Significant level is going to be that if, you see, if P of A is going to be less than 5%, anything less than 5%. Okay, if this is going to be the case, then we can assume that A, okay, the event A is not going to be, you know, it's not occurring, if you like, not occurring. Okay, or this means, or we can say that the P of A is almost 0. Okay, we go with the 5%. 5%. This 5% is going to be called significant level, if you like. When we get to the end of the course, this is going to be good when we want to do those predictions. When we get to the end of the course, we are going to create a situation that we can talk about any level of the significant. You see, if you do something, for example, sensitive in chemistry, physics, even 5% will be too much. They will lower it, okay, to the 2%, 3%, but for the time being, we're just using this commonly accepted norm that if it's anything less than 5%, it's not significant. Okay, that's going to be the one. So if you want to make any comment on the problem that's coming for the time being, make sure that you apply this rule, not your own idea, okay? Because this is going to be the norm for the statistic. Okay, so I'm going to give you 2 examples to see how we are going to characterize this type of ideas, okay, from everyday life. This is going to be, any question? So the 5% is the one that we are going to be interested in. Let's say we're going to check this one. You see, we have question number 5 here. 5 and 6 are this category. I do the 5 first. What is 5? We investigate 150 American flights. AA stands for American flights. Okay, we investigate 150 American flights. And we find out that out of 150, 105 arrive on time. Okay, so what we are interested in, what is the estimated probability of AA flight arriving late? Okay, so we want to find, let's do the first part. So what we'd like to know is You can create a formula. So that's going to be number 5. Number 5, part 1, if you like. So you may take the A to be A. A is going to be a flight. It's going to be event that a flight arrives on time. Okay, that's going to be A. If this is going to be arriving on time, then A complement would be the opposite. A flight arrives late. You see, that's the situation you're going to have. Arriving late or arriving on time. So in this problem, you are interested in the second one. So you would like to find what is going to be A complement. You know that you have to find the probability of A, then use complementary rule to get it. There are different ways to do it, of course. Okay, so let's find P of A first. Remember P of A, the probability that the flight arrive on time. We know that we have 150 flights. Remember, it's going to be N of A over, just explain it for you. Remember, this is N of A over N of S. The total number of the flights are 150. Out of 150, 108 arriving, arriving on time. So you may use your calculator to get this number. That is going to be, if you using the calculator, what's going to be the number for this one?
0.72.
0.72. Yes, 0.72
Yep.
is correct. 0.72, which is 72%. Okay, so probability of getting an on-time flight is going to be 72%. So the complement is going to be the other way around. Remember, the complement is going to be 1 minus P of A, or 100%, which is going to be 1 minus 0.72. So it's going to be 0.28, which is a 28%. So probability of getting a late arrival is 28%. Of course, there is another way to do it. This is 108. This is the number that arrived on time. If you subtract it out of 150, that gives 42. So 42 flight arrive late. So 42 out of 150 right away, which is going to be the same thing. It's going to be 28%. Okay, so there is 28% chance that the flight will arrive. You know, this is just write down for your information that there is 28% chance that a flight, okay, will arrive late arrivals. Okay, that's the first part. Any question? Note that 28% is, okay, is bigger than 5%. It's very much bigger. Okay, so what is your question, your answer to the second part? So look at the second part. This is where we ask you to make a comment. We want to know, is it unusual for an American flight to arrive late? Yes or no? So look at what we have over here.
Yes, right? It's
Yes or no?
yes, it's unusual.
I think no, it's not unusual.
You are right. It's not any. Remember yes, if you say yes, you're talking about from a management point of view. You're running the company, so it's just 28%. But remember, 28% is significant because it's bigger than 5%. So if this is, remember, if it's going to be less than 5%, it's like 0. But this is bigger than 5%. So since it's bigger than bigger than 5%, so you got to be worried about, because it's almost 30% chance that the flight would arrive late. So if you get late arrival, you are not going to be surprised because you already got it here. Okay, so the answer to the second part is going to be this one. You see that the probability of getting a late flight is 28%, but this is bigger than 5%. When it's bigger than 5%, you see, you are sure that it's going to be happen. So it's not unusual we get a late flight, because 30% of their flights are always late. So we are not going to be surprised. Okay, so the answer is no. It is not unusual for a flight, for a flight to arrive late. That's about. Okay, any question? So double check when you want to make a comment for that idea that you have. You see, we would like to get the numbers, that's fine, you know, we get the formula, but at the end, this is our interpretation is going to be important. That we're going to do. But remember, we set that 5%. We set that 5%, 28% is bigger than 5%, but so it's significant. So it's significant, so you will get regularly, you will get a late arrival. So it's not going to be unusual for American flights to arrive late. Okay, any question? So we have something nice for you on the quiz to make a comment for us, okay? And then we have lots of fun for some of your comments, so double check. Now, I have another one for you. Just make sure you get it. That's number 5. Let's see what's number 6. The one that I told you is sensitive is number 6. What is number 6? Number 6, assume that the study of 500 randomly selected school bus. Okay, so we check 500 randomly school bus or buses, and we find out that 483 arrive on time. So the question is it unusual for a school bus to arrive late? The same thing. So again, you have to find out what is the probability that the school bus would arrive late, and then you answer it. You can see it from here. 483 out of 500 arrive on time. So again, different way to do it, but I just want to practice these formulas that we talk about it. So this is going to be number 6. So you can take the A to be a school bus, okay, a bus, let's say, arrives on time. Then your A complement would be arriving late, okay, a bus arriving late. Okay, then the probability of on time one, on time, the total number that we consider on time, we get 483. Okay, 483 out of what? Out of 500. This is the number of the buses that arrive. Okay, this is going to be, so we check this one, use your calculator, what's going to be the number? To get, it's going to be almost something like 90%.
It's 0.966, 96.6%.
96.6%, okay. That is the arriving on time. So the late arrival is the complement. It's going to be 1 minus P of A, or 100% minus that number. Okay, it's going to be like 1 minus 0.966, or just a percent. So for the percent, that give you the 1. Okay, this is a 0.034, I think. So it's going to be 3.4%. So P of A complement is going to be 3.4%. You see this one? This is probability of getting a late arrival, which is very much less than 5%. Since it's less than 5%, it's like 0. You see, we can see this one like 0. So this means probability of getting a late arrival is 0 almost. So of course we are going to be worried about, because this is very unusual for a school bus to arrive late. Okay, any question? So since less than 5%, this number is not significant. So this won't happen. Okay, AC, it's rarely happen. Okay, so there is only 3.4% chance of a late arrival. Okay, arrival, so it is unusual. So it is very much unusual to get a late arrival, And that's why we get worried. You see, if the school bus arrive late, you are going to be worried about your kids, because you know that it shouldn't happen. So that's a sort of commenting, something easy, but just using it to the fact that we have and make a nice comment about it. Okay, you have some in your books, but we create one and we give you one just to make those type of judgment for us. Okay, so that's good. That was the number 5 for the probability. Any question? We have another one regarding those at most, at least. Let's do that one first, and I give you a short break, then I come back and do the second part. You see this type, we talk about it, remember? We want to make sure that you remember those expressions of the at least, at most. So the situation is over here. X is the number of the TV sets, television in a household. And this is the probability, chance. So you know that in a household, you may get 0 televisions, 1 set, 2, 3, 4, and 5. And these are the possibilities. So if you check as a household, there is 12% chance that you have 4 TV sets in your rooms, 3, etc. Okay, so it's going to be the one. And so we ask a question about the probability. The first part, what is the probability that the household selected at random has at most 3? I talk about this expression, so we just check it from now and at the end. When we get to the other part, you are going to be able to find this percentage yourself. But this would be one of the questions we're going to have, okay? So let's see what is at most mean. So that's a number 4. Okay, number 4. Number 4 for part 1. The number of the television is X. So in number 4, you want to know the numbers to be at most 4. Remember, at most is the end. So when you say at most 4, you say at most 3. So this means your X is going to be less than equal to 3. Okay, less than equal to 3 means what? Means 3, 2, 1, 0. So this means X can be 3, 2, 1, and 0. So you are going to add those probabilities together. So the probability of the first event, if you like, you can call it probability of A, is going to be what? Is going to be probability that X, we get the 0, we get the 1 set, we get the 2 sets, and we get the 3 sets. Now we go to that table and you substitute, you see. For the 0 sets, we get 8%, 39%, 28%, and the 9%. You add them together. So this is it. It's going to be 8. You can go with the percent, add it at the end, or just write down 8%, 39%, that give it 28%, and 9%. Okay, you add all those numbers together to get the total probability that you are going to have. Okay, any question? So if you add them together, what's going to be the number? This is going to be, that's going to be 18, 26, 34. We get the 3 back, and that would be 5, 8. I think it's 84%. Okay, 9 and 9, 18. That get 26, 26, 34. Yeah, that's correct. Okay, so there is, so if you check one household, there is going to be 84% chance that household would get at most 3 televisions. Okay, any question? So just make sure you don't miss it. The at most means 3 done. Then we want to check the at least, the other way around. So what's the probability that we get at least 4 TV sets in the household? So at least 4. 4 is the beginning. Let me say at least is the beginning. So X got to be greater than or equal to 4. Greater than or equal to 4 means you start with the 4 and you go on forever, but you have only up to the 4 and the 5. Okay, if you get more numbers, then you continue getting more. So the probability of your event now is going to be event that you are going to have 4 TV sets, and the event that you have 5 TV sets. And 4 and 5, you see, for the 4 is 12%, and for the 5 it's 4%. So it's going to be 12% and the 4%. Add them together, so that give you 16%. So there is a 16% chance that 60% chance that the household would have at least 4. Not many households would have 4 TV sets or 4 or 5, and you just put them together. Okay, so this is going to be, again, we are interested in these 2 terms. Make sure that don't miss it, write it down correctly. At most is the end, so 3 done. At least is the beginning, 4 up, and just collect it from the table. You are not going to do anything else because the percentage would be given to you. That's it. This is probability part. 3 questions. Okay, I'll give you a short break, 10 minutes. We come back, we do the other part. The other part is, that's it, percentile, then Q1, Q2 to get the box plot, and checking for the outliers. Okay, 3 questions here, 3 questions there. It's going to be 6
So,
questions.
Professor,
Yes.
can I take a picture of number 6 real quick? I'm missing a little part of that.
Solution, you mean?
Yes, the number 6 work.
Is this is, oh, number 5, number 6. Oh, number 6.
Yes.
That's number 6.
Yes, thank you, Professor.
Okay. So see you in 10 minutes to talk about those 3 other cases. Okay, so let's go and do the other ones. Okay, so we did the number, that was number 4. Now, the other one are going to be, this is it. I do number 3 first. It takes times. That's a percentile. Remember the position of the given data values. We give you a data set, and there are 2 cases. The case 1 is the numbers would be given to you. Then you are going to find the ranking of the numbers or the percentile. The other one is the percentile would be given, and you are going to give us the numbers. We give a couple of them, but it's going to be one question. Okay, we are not going to give you Q2, Q1, Q2, 3, because you are going to check those with the box plot. Okay, so this is it. I do a couple of them for you to show you. So this is going to be number 3. Number 3 percentile. For the first part, okay, for the first part, the values are given. They ask for the ranking. So for example, X equal to the 149. And then you've been asked for the ranking, the K. Okay, remember the formula that we have. The K is going to be equal to the percentile is equal to the number of values less than X, less than 149, divided by the total number. Okay, total number of observation or values of values. Okay, for this set, the total number, you have 40 numbers. Okay, the top and the bottom is opening 40 numbers. Then 149 is here. Okay, 149 is here. So what you're going to do, you're going to count how many numbers before the 149. These are going to be 10. Okay, 10, and you get 7 here. So there are 17 numbers less than 149. So that gives you 17. Okay, that gives you 17 on the top and the 40 on the bottom. Whatever you have, you multiply by 100, because this is going to be decimal number and you want to change it into the whole number. Okay, so this is going to be times it by 100, or just get the decimals and change it to the kind of whole numbers. So this is going to be 17. You divide the 17 by 40. Okay, that gives you something like 0.45, and you multiply it. Okay, it's going to be kind of 42.5. This is going to be the number that you have. When it's a 5, you can keep it, or you can round it up all the time to make it as a whole number. So I'm going to round it up and call it 43. It's not 43%, it's a ranking for the 3rd position, if you like, percentile. So K is equal to the 43, or we can write that the percentile, you see the ranking P of 43 is equal to the 149, or 49 is on the 43rd percentile. Any question? So it's going to be easy case. I'll do one more for you. For example, you have 210. 210, so you find the K. K is equal to the number less than 210. You go and count how many numbers are you going to have. This is 210. The number below it is going to be 10 and 10, 20, 21, 22, 23, 24. So there are 24 numbers. So it's going to be 24. 24 over the total, which is a 40, then you multiply by 100. Okay, you multiply by 100 to get your result. This would be easy because you can simplify these 2 by 4. So that give you 10, and the top would give you, okay, would give you 6. So the result would be 60. So K is equal to the 60. This is the rank of 210. Okay, so we can say that the P of, okay, you can say that the P of 60 is going to be 210. Okay, so these are going to be an easy case. You have a couple more you can do it yourself, or no, it's not difficult really to get those numbers. For example, the next one is going to be 35. So for the 35, K would be equal to the number of observation less than 35 is going to be 6. Okay, is going to be 6 over 40 times it by 100. So that give you 15. So K is going to be equal to the 15. So P of 15 is equal to the 35. Okay, that's a ranking of the 35. And the last one that we have is 250. X equal to the 250. So the K would be the number of observation less than 250 is 29. 29 over 40. Okay, 29 over 40. And then you divide it, multiply by 100. Multiply by 100. And it's going to be almost 72.5. So you call it 73. So P of 73 is equal to the 250, and then you done. Okay, that's part one. We just give you now one or two of these numbers to do for us, not all of them. Okay, any question? That's part one. Part two is the other way around. Part two takes a little bit more time. The part two, the ranking is given to you. You see the part two. The ranking P20, 33, 85. This ranking is given, they ask for the value, the X. Okay, so part two. For example, you want to know what number would be corresponds to the P20. Remember, we did have something we call it location number. You get the location of the values and then you go to the list and find it. So in this case, the ranking is given to K is equal to 20. The total number of the observation is 40 and the L is missing, location number. The formula for the location number is K times N over 100. It's given to you, you can bring it to the test. Now we substitute, so that gives us 20 times 40 divided by 100. That gives you 8. L equal to the 8 is a whole number. Now we did have two different cases. When it's a whole number, you are going to go to the, you are going to go to the data sets and you find the numbers that corresponds to the 8th position. You see, you go to this one, 8th position. This is going to be the case in the 8th position. It's a 44. And you pick the numbers in the 9th position. Then you find the average. So it's L, which is going to be 44. Then 1 up to the L plus 1, which is 9. That gives you 48. Then the values that you are going to be interested is the halfway. X is 44 plus 48 divided by 2. Okay, so that gives you 92 over 2. So the number is 46. So the number in the 20th ranking percentile is 46. That's a case one. Any question? So there are two cases. When this is not a whole number, you round it up and you do the job. But when it's a whole number, we talk about it. You must get the number halfway between the one on the 8th positions and the one on the 9th positions. On the list, the 9th position, 8th position is 44, the 9th position is 48. That's why we pick the average. Okay, any question? Let's get one more to get the something which is not going to be whole number. The next one should give us, the next one is P33. Okay, so what value corresponds to the 33rd percentile? So P33. Again, what we have here is the K, the ranking is 33, the total number is 40, you have to pick the location number, L. So the location number is what? It's going to be K times N over 100. So it's a 33 times 40 over 100. Okay, this is going to be the case that we're going to have. So we simplify it. Okay, if you multiply them together, 1 0 out, that give 132. Okay, 132 over 10, which is 13.2. You see, 13.2 is not a whole number. When it's not a whole number, you round it up all the time. Okay, round it up, and that give you 14. So you consider L to be equal to the 14. Okay, any question? You go to the data set and you pick the numbers in the 14 position. 10, 11, 12, 13, 14. Okay, so the number is 121. So in this case, that corresponds to the X equal to 121. So the number on the 33rd ranking is 121. Okay, so when it's not a whole number, you round it up. But when it is a whole number, then you have to consider those L and L plus 1. Okay, so this is going to be the case. Any question? We are not going to do Q2, Q3 would be special cases for that one. So I just quickly give you the solution for 85. K is 85, N is 40, L is missing. So the L is going to be Kn over 100. K is 85, that's the 40 over 100. If you simplify it, because these zeros would be off and the rest are divisible, that give you 34. So 34 is a whole number, so we have work to do. Is a whole number. Okay, it's going to be the whole number. So what we have to do, we pick the number that correspond to the 34 from the table, X1. 34. That's 30, 31, 2, 3, 266. Oh, 3, 4, 277, 34. Okay, 277. And the next number in 35 position, that give it 284. 284. So your number is going to be the average. So the X would be 277 plus 284 divided by 2. Okay, divided by 2, that give it 280.5. So the number on that ranking, 85th rank, is 280.5. That's it. Okay, it's not a difficult operation. Just make sure you don't pick the wrong, the wrong choice when you want to go with. Okay, any question? Again, I repeat it. Some people, they find the L and they stop. You're not done. L is the location of the values, but what is the value? Okay, this is just the location. Location number, not the value. The value is X. So you have to go to your table and check those numbers. That's question on percentile. Okay, any question? So that would be number 3. Number 2 is the famous box plot. Okay, we give you a data set. You are going to find the Q1, Q2, Q3. You can find it with your calculator if you like. And you know that you need 5 summary numbers, the maximum, the minimum, Q1, 2, 3, you put it on the number line, and you describe the resulted box. Okay, so this is going to be the solution of number 2, box plot. Okay, in this box, this is what we have. You have to order this number or using your calculator. Either one is fine with us. Okay, to find those 5 numbers. The calculator give you those numbers right away. The way you did it for the standard deviations that we did the other day, give you the result, and otherwise by itself is also should be fine to get these numbers. Okay, not a big deal. So you have to order it. There are 18 numbers, so this is the way you are going to order this. Okay, so the first thing to do, you have to order the list, order the data set. You have 18 numbers, make sure you have enough room for the 18 numbers. Okay, there you are. And if there's going to be repetition, you have to repeat the values. So we start with the 8 and it's repeated 4 times. So this is it, 8, 8, 8, 8. That's the 4 numbers. Then we get a 16, 16. Just check to see, make sure it's the same. That I'm going to have is 8, 8. Yes, there are 4 8s. Okay, it's going to be 16, 16, 2 16s. Then you get a 24, 40, 40, 48, 48, 56, 56, 64, 64, and 64, 72, 88. Again, the calculator will give you this result. You know, if you want to use calculator, we don't mind to get these numbers done. Okay, so this is going to be the case. That is going to be the case. Now we are going to find the total number must be 18. I'm going to check to make sure I get the 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Did I miss any number? So 4 8s, 2 16. I have 24, 240. And I get a 48, 48, 56. Then I have 3, 1, 2, 3, 64, 72. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. What is missing? Oh, I have 464. 1, 2, 3. I need one more. 464. It's a 464. Okay, just double check it. Make sure you get it right. Yes, there are 464. Okay, so there you are. The Q2 is 18, 9 to the right, 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is going to be 9. So there is nothing in the middle. So the Q2 is going to be the average. It's going to be the average of the 40 and 48 divided by 2. That would be 88 divided by 2, which is a 44. So that's a Q2. You go to the right, to the left. Okay, you have 9 to the right, 9 to the left. 9 divided by 2, that gives you 4.5. So it's going to be 1, 2, 3, 4. 1, 2, 3, 4. The one in the middle is going to be Q1, which is 16. Okay, we do the same thing here. 1, 2, 1, 2, 3, 4. And that would be 1, 2, 3, 4. So the Q3 would be 64. 64. Any question? Max and the min. So there you are, the 5 numbers. The minimum is 8. Q1 is 16. Q2 is 44. Q3 is 64. And the maximum is 88. That's it. This is the 5 summary numbers. Put them on the number line. Okay, connect the quarters together to get the box. So this is it. The last number is 88. So you need to divide them into tens. Okay. So this is going to be 10, 20, 30.
Was there 4 64s in the last equation?
Yes, there are 464.
Okay.
Okay, 10, 20, 30, 40. So that would be 40, 50, 60, 70, 80, and 90 over here. Because the maximum is 88, so we have to go as far to get that numbers. Okay, identify the one that you have, these 5 numbers. We have the 8. Suppose this is going to be the 8. So we put the number line on the top. So that gives us the minimum. Q1 of the 16. That's it. This is 15. Suppose this is 16. That's a Q1. 44. 44. So the 44 is going to be somewhere here. Okay, it's a 45, 44. And then the Q3 of 64. So it's a 65, 64. And the 88. And this is going to be 88. Okay, so you are interested in Q1, Q2, and the Q3. So connect these together to get the box. So the box would be constructed by the corners. That's a box connected to the max and the min. Max and the min. That's it. Any question? Now the comment. You compare it with the center of the box. This is your center, Q2. It's shifted. You see, if they get the center of the box, you see this is going to be the center of the box exactly in the middle. Okay, so this is going to be the center of the box, and this is your center. Okay, it's shifted to the right. So the distribution is not symmetric, shifted to the right, skewed to the right, or skewed negatively. Okay, so this is your comment. The distribution is not symmetric, not symmetric. Okay, it is shifting to the right, so it's negatively skewed. There must be something wrong with those numbers. Okay, so that's a box plot. So it's not a big deal. All of them can be done by the calculator, especially the first one. You just drop the numbers in, for the mean and standard deviation, quickly give you them. But it's not a big deal even to do it manually. Okay, but if you use your calculator, the calculator give you this code in this format. Okay, but you have to bring it up on the paper so that I can see it to give you your points. Okay, so we give one box plot, not a big deal. You have quite a lot in your book to practice. Okay, that's a box plot, and the last case is checking for the outliers. Okay, these outliers, everything is included in the box plot, but it would be too much for one question. We usually break it in 2 parts, and we ask for the outliers. Let's see, this is going to be question number 1. Quickly, I give you the first one. So for the outlier, we talk about it. There is an interval that we call it the safe zone. Okay, so that interval would have endpoints, lower fence, upper fence. We are going to find those, and then if anything outside that interval, it's going to be an outliers. Okay, so there you are. I do number 1 for you. Okay, number 1, part 1. So this question would be related to the outliers. Okay, outliers, I just remind you how we're going to find it. You see, for the outliers, you have to identify lower fence and the upper fence. If you identify this one, then anything outside is going to be outliers. So the outliers are going to be the one in here or here. Now the way we're going to find it, you have the IQR, which is the Q3 minus Q1. Then the lower fence is going to be Q1 minus 1.5 IQR. And the upper fence is going to be Q3 plus 1.5 times IQR. That's it. So the rest is going to be algebra to get these numbers. Okay, so we need to find the Q3 and Q1. So we have to order the data set. So I'm doing the part 1. So order the data set, data values. Okay, if you order it, this is going to be the order that you are going to get. You see, I do the first one. The smallest number is 400. And the biggest number is going to be 521. So this is going to be the ordering. You start with the 400. Okay, 400, 506, 511, 514, 517, and the 521. That's it. So 1, 2, 3, 4, 5, and 6 members. Divided by 2, that give you the, you don't need the Q2, but you have to find it to get through the Q1 and the Q3. Okay, so it's going to be 1, 2, 3, 1, 2, 3. So the Q2 is going to be here. You're not going to be interested in that, you know, it's going to be the sum of these numbers divided by 2. You don't have to find it because you don't need it. But to get the Q1, you have to go to the left and the right. You have 3 elements. So it's going to be in 1.5. It's going to be, that's it. 3 divided. So 1 to the right, 1 to the left. So this is going to be Q1, 506. Again, this would be Q3. Q3 is 517. Any question? Now go and find this. Get the IQR. So the IQR is the difference between the Q3 and the Q1, which is 517 minus 506. It's 11. That's IQR. Get the lower fence and the upper fence. Lower fence is the Q1 minus 1.5 times IQR. Q1 is 506 minus 1.5 times 11. It's going to be 506 minus 1.5 times 11 would be 16.5. So the difference is 489.5. So that's a lower limits. Any question? The upper one is a Q3 plus 1.5 IQR. So Q3 is 517 plus this number 16.5. And for the 16.5, that give you 533.5. That give you the uppercase, upper fence. So this is where you are. You have the 489.5 and the 533.5. This is your your fences, your zone. But where is your numbers? The number start with the 400. So 400 is here outside. The next number is going to be 506. So you are going to be in, and you end up with the 521, which is in. So as you can see, 400 is an outlier because it's outside the fences. So 400 is an outlier. See, this is how you're going to identify it, whether you get the outlier or not. Any question? The second one won't have any outlier. I'll just give you the number, check it for yourself because I don't have time to give you all the details, but that's it, no outlier. And these are the numbers that you have, you check it for yourself. Q1 would be 7. Q3 would be 14. So it's clear that the IQR would be 7. IQR would be 7. Your lower fence would be negative 3.5. And your upper fence would be 7. So all your numbers are going to be inside, you see. This is a negative 3.5, and this is 7. But if you check your numbers start from 3, and you end up, must be something wrong with this one. Sorry, upper fence is, I made a mistake here. Upper fence is, your upper fence is going to be 24.5. So this is going to be 24.5. Okay, your numbers start with the 3 and you end up with the 20. So everything is inside. That is why you have no outliers for this one. Okay, so that's it. Any question? So study, this one, and you'll be fine. Okay, we give you a take home. Usually we give over the test, not for this quiz. But if you study this, you